everyone, if you get yourselves nice and comfortable, welcome to this is the final session of 2 days worth of engineering theatre at Rail Live 2024. It's an absolute pleasure to have you all here. None of you are football fans, I guess. So thank you so much for being here. Thank you again, and the second last time I'll say this over the last 2 days. Thanks again to Pandrel, who have sponsored this theatre. I am delighted to be joined by Simon Skinner, who's the engineering director at SPL Powerlines. Yep. We're going to be talking... Actually, OK, so electrification is a thing that's been talked about in stages like this for years and years. And it's like, OK, what are we going to say that's new at this point? Well, thankfully, quite a bit, because we have been doing a bit of electrification. You've been learning quite a bit in that process, and we're going to dig into some of that. The big picture scene is that, OK, we all know that there isn't and needs to be a rolling program of electrification. So I'm not going to dwell on that, because we're not going to get anywhere by saying that repeatedly. We'll have a change of government fairly soon, and hopefully that'll give us an opportunity to make that point again in a fresh manner. Meanwhile, the work that has been happening behind the scenes on projects like Midland Main Line electrification give us some of the leverage to make that case again, and that's kind of what I wanted to dig into, really. But first of all, Simon, maybe introduce yourself briefly, but also tell us what electrification you are currently working on and is happening.
Yeah, hi all. So I'm Simon Skinner. I'm engineering director for SPL. I've been working predominantly on Midland Main Line for the last 7 years. About 20 years in electrification systems, both light rail and also heavy rail. I was the CEM, or Contractors Engineer Manager, for the first phase of Midland Main Line, about 200 single track kilometres. And been through the pain, so I've been en route generally for about 7-8 years for Midland Main Line, where we've started from scratch and gone through quite a painful curve of learning in terms of single track kilometres, or the run rate, and trying to reduce that down.
The pounds per, that unit rate, that pounds per, or million pounds per kilometre of electrification is the key number.
Yeah, it is. And it varies on complexity. So our route is particularly challenging in terms of the Victorian infrastructure. So we've got a lot of route clearance, a lot of track lowers. A lot of technology has just come in to support doing less of interventions and more electrification, which is great. Interestingly, the metric, the single track kilometre metric, is highly spoke about, lots of pounds in the ground, MVP, but the actual, the sticks and strings, as I call it, the structures and the overhead wiring wires, doesn't actually cost that much. It's the interventions that do. Yeah. So knocking bridges down, doing track lowers to support, to squeeze the wires through, really, really costly and expensive.
It's an interesting point. So you picked up on Midland Main Line about the time that I moved off Midland Main Line. So when I used to be at Atkins, and so that was my life when I started in the industry, was working on all the different sort of engineering stuff. In fact, all those interfaces, whether it's moving. Actually, the thing I spent a lot of time doing was moving power lines, not the ones that power the trains, but the big super HV ones that make our OLE look like nothing. Yeah, and that's all that stuff. But the interesting point I wanted to draw on was the difference so all those designs that got put out, all the bridge reconstructions, all the heavy civil engineering, that from the previous version of that electrification design that then was paused, parked, whatever you want to call it. Yeah. And then, as you say, the fresh design, as you and the team have picked it up. Yeah. That difference is significant. I thought it's worth talking about. There's a lot less intervention in terms of heavy structure. Yeah. So what's changed? What's allowed us to sort of think differently?
I think for London to Corby, we were quite lucky off the back of GWEP. They did a lot of work associated to foundation approaches. So the ORI, the empirical method of using lookup charts, in essence, for foundation assessment. So we're able to apply a quite linear, lean technique in terms of foundations. And that's where a lot of risk is held from an overhead line perspective. So I think we achieved about 90% of a single section type. So we did a lot of work up front about everything had to be the same, everything had to look the same, everything had to be the same from vesting point of view, material vesting. Yeah. So we came off the back of Great Western, so we knew what not to do, I guess, rather than what, and we knew what to do because we had quite a lot of experience in the team that allowed that. We were quite lucky in London to Corby that in your world, the interventions were done up front. So the pausification, as we called it on Midland Main Line, the electrification stopped, but the route clearance interventions didn't. So we were fundamentally route clear, in essence, that enabled us to electrify the route a lot more efficiently. But going to the existing or the new electrification we're currently building, which is we're going to energise about 70 kilometres in about 6 weeks' time, hopefully. we've reduced the track interventions down even further. So we've applied technology that technical authority be applying, the VCC stuff, where surge arresters, we're painting bridges, we're reducing clearances down now to 80, 100 mil between the uplifted contact wire and the top
voltage controlled clearances, folks.
Sorry.
I must catch Simon and I are going
to...
We have to make sure we don't disappear off into acronym speak, but voltage controlled clearances, which is, as you say, surge arresters, these new paints, just allow you to reduce the amount of airspace, insulation required, which then means you don't have to smash so many bridges down. Yeah,
correct. So the technical authority and the industry has done a lot more to reduce the amount to enhance what we've always known and make it better. So we know a little bit more about how pantographs perform, and we can start reducing those requirements even further. That allows us to do less at bridges. Our track lows are less. So instead of 100 mil track lower, we can go to 50, 60 mil, which is quite significant in terms of track access opportunity. So
I suppose an analogy that... that's quite, or a way to frame this actually is that as we've ramped up electrification since the late 2000s or the early 2010s, the risk aversion was quite high.
Yeah.
And so some people might say, well, why aren't we building it how we did it? Anyway, why are we not getting Pete Dearman in and we're just building it all like we built East Coast? Is that, well, because of the structure of the industry, the risk aversion is much higher. Yeah. We have a better understanding of that risk because our engineering is more complex. And in a way, what we're benefiting from now is the technology to allow us to model and understand things better, and some of the interventions as well, the data management, all that stuff has sort of come up to meet that risk aversion, to allow us to then bring the level of intervention back down again, because we understand the risks, which means we can build a more accurate, build in a more accurate corridor for trains to pass through. That's one of the ways that people often challenge with, why are we not just building it exactly like we did East Coast Main Lines? Well, because actually we have a better understanding of risk. But that means that there's a little bit of risk aversion. And so, as you say, as we'll talk about, some of that modelling, some of the modelling that's been done by some of your colleagues allows us to understand those risks better. Things like dynamic modelling of pantographs, some of that simulation running instead of physical running, some of that stuff that I'm sure we'll touch on.
Yeah, I mean, there's always a refer to what we did yesterday, so this back to the future mentality, that East Coast was very good, but it was pretty quick and dirty, so we're sweating those assets as we speak. It's not independent
headaches.
We get there's a lot of dewirements, a lot of risk associated with equipment or poorly maintained equipment, perhaps. So whilst the run rate, the STK rate back then was very cheap, and it was a different environment, they didn't have interoperability to deal with, and the safety culture was somewhat different and less challenging than we're dealing with, and the equipment that we're installing is a lot more expensive. But I think we're hitting the type of quantities that they did back then, but it just takes time. You need to...
As you say, and I won't hammer this point too hard, but you have to be doing it to learn from it, right? And the benefit of Midland Main Line and the work that you've done on London to Corby, and then as you've been working your way further north up the Midland Main Line, you're learning some of those lessons and picking some of the... I think we're going to talk about some of the specifics of the lessons, I think, momentarily. So I want to go back to piles in a second, but I wanted to just broadly talk about lessons learned culture and how are we making sure that the key thing is that as we learn these lessons is that not just as organizations but as the whole industry we're remembering them, so and not risking just having to relearn that stuff again. So can you talk a little bit about
so my view on this is I think the client, we're on Eastern, the client has a tendency, and they're starting to disposition a lot of their responsibilities onto us as contractors. I know CVL were looking at self-assurance. It is a way. We're the lead design organisation as well. It's both an opportunity and also a burden. So we're a design and build contractor. We're not just a build contractor. So we've got a responsibility under CDM as well to make sure what we build, what we design, we can actually build. So we've got skin in the game at the very commencement of a contract. So we design something that we can build. We design something that we can get materials for. There's no point designing something that you can't actually get the materials for, which can happen. So a lot of our approach was standard stuff, which is every overhead line structure needed to look the same. It needed to have the same components, and it's dead obvious, but what you can't have is on projects such as Gospel to Barking and others, every structure looked the same. Multiple designers all working on one structure. One was responsible for the foundation, one was the steelwork, one was this, one was that. Very, very complex. Huge integration, drives up cost in terms of white-collar staff, and the only people that would save or yield any opportunities were the designers, and that causes delays, and ultimately your energization dates start to slip because you just can't get product. If you can't get product, you can't build. So we were very driven on getting all the outputs from the designer, getting it right first time. We didn't accept any form of greyness. We didn't accept bubbles around stuff saying...
Cursed CAD bubble, yeah.
And Network Rail, the project, Darren mentioned the word collaboration. There was a sort of a one united team to actually sort of look at that success, which was quite rare. We didn't have overly complex alliancing or anything like that.
Okay, yeah. So you alluded to it earlier when you were talking about 90% sort of commonality. We'll come to that and break down what that was about momentarily. Repeatability is key, isn't it? You want to get rid of as many novel features, whether it's a novel OLE structure or whether it's all of those really expensive bits, which are, where you have to reconstruct a bridge, particularly in urban areas, particularly extensive structures or historic structures and all these things. Get as little of that as possible, and as much the OLE should just be the same thing every span, the same structure. So talk about how is there a compromise to be made and you go for a longer average pile, but it means that it's the same thing and you pile up, or some of the stuff that allows you to, that 90% figure you're talking about is it's a 610 steel, it's the same thing that you're putting in everywhere. Every single structure has the same thing. So talk a little bit about how you actually achieve that.
So everybody, particularly an overhead line engineer, will have a view on whether or not you should design particularly if you're a designer, every pile should be potentially designed to the nearest millimetre, the nearest newton. What you've got to think about it doesn't really matter. The tube lengths come approximately between 11 and 12 metres, so you could just chop that in 3 or chop it in half and say, do you know what, 6 metres is fine, but it's all dependent on the strategy of what you're looking at. We took a strategy and we were in between standards. We have a lot of what they were, PAN 101. It was an intent of a standard change that then led to a Network Rail standard, CIP 72, but he spoke about actualised loads. So we used actual loads, and it's very complex because we were releasing pile schedules before the overhead line design actually was fully committed.
Which is risky if you don't have all your ducks in a row.
Which is risky, and then you've got to then make sure that you add a little bit of sort of engineering contingency or fat in there. Then the loads had to be revised. Versus potentially over-onerous requirements, and there's something in the middle, what I define as a sweet spot of something that's designed to the millimetre and potentially rounded up for linear productivity. But the biggest risk on electrification jobs is foundations. So getting them in the ground first is actually really key and really obvious. But potentially doing the worst case could actually better the program, and we halved our foundation programs by putting 90% of 610s in. And we did a lot of work around that just because we didn't want bespoke foundations. Yeah. And that was our intent, and that's what we decided to do. Every job is different. Yeah. We had good ground conditions, not low line rock or anything like that. But it's a point of discussion and one that needs a lot more attention. But in opportunities for self-assurance, delivering foundations off early AIPs or a proven outline, a proven principle, grip 4 as it was, shouldn't be discounted for me because once the foundations are in, everything else can be counted because it's easy. You can't count foundations because you never know the risk of
something not going in.
Yeah, correct. Yeah, so mobilisation of foundations before anything is a huge opportunity.
There are horror pictures that keep sticking with foundations. That's right, we're having a conversation about foundations at 2:15 in the afternoon. Some of the horror pictures from Great Western where piles had been put beyond troughing routes that were still there, and some of these horror stories. So that's been avoided. That's definitely, I know that's been avoided.
Yeah.
The main line. What went into making sure that you knew what was happening so that you weren't turning up at a place where a pilot needed to go and you had no idea what was there, that you knew what was there, you knew where it was going to go, you knew everything else was out of the way. So talk a little bit about that.
We did a lot of work with, again, we were design and build, so we before we released the drawings to AFC, or proven principle, proven construction, we actually had a delay of 4 weeks in our design process. We actually went out and verified the position of every single structure. So the consultant drew the pictures, little sticks, and we'd actually physically go out with the design and construction CREs, the responsible engineers, and just verify that those positions could be actually be used. So when we rocked up with a piling rig that cost a lot of money, it went in once and once only. We didn't have to stop and then go around a big full circle of assurance to move it, and the knock-on effect.
And you had contingency if you did get the first method of installing that big, what we're talking about, a big metal cylinder that you wallop into the ground.
Yeah.
I might be preaching to the converted here, but for some of you might not know. Big cylinder that you wallop into the ground, a hollow cylinder. You had, right, so if you install it the first way with the Movax is the first preference, but then you had you always made sure that you had the backup if you needed it there. So you didn't just abandon half-installed piles in the main, you had that control.
Yeah, that's right. I think we had about, so I think we put in about 3,500 foundations. We got a hit rate about 93% of CHS or 610 CHS, or piles, tubular piles. And the rest of them are generally 1 metre concrete augers, but the cost differential is quite significant. So it's about £3,000 to £4,000 roughly for a 610, versus at the time about 10 or 15 for a 1 metre concrete auger. So the more you can get 3 of them in for every one of a bespoke. So the maths are quite easy, but I mean, I think one weekend using conventional methods as well, we put in, I think, 115 foundations in a 56-hour block using sort of conventional plants. So we got the norms. If you give us the access, we got the norms. But we did a lot of work up front in terms of understanding what the ground was like. We pre-augured some foundations so you could loosen up the material before we went in there. Lots and lots of work, but it's all about stating the obvious, which is get your foundations in, and everything else is then very, very easy. But you leave one behind, then you can't complete the construction unit.
It's got to be a factory production line, right? So we'll be scraping the mud off our boots in a minute, but just sticking very briefly to the point, and this is a point, as a designer, obviously, this is the thing I would say, but it is the right thing. And you allude to this in discussion we've had before. Getting the design, really making sure you got the design right, including walkouts, virtual or otherwise, to make sure that thing goes where it's to be, is so much worth it, because the money you burn on site of not being able to put the thing where is way more than you'll ever spend of a bunch of people safely, importantly to say safely in an office, or safely going out and viewing a thing to check that it can go in. So that's really important, right? That's a really important thing.
Yeah, we started to remove boots on ballast, which is what we should be doing in this industry, to remove the sort of the safety tension about putting people out to stop. We started to use drones now, so we're starting to use drone surveys to identify clashes, in addition to all the other tools that like RILA, LiDAR, that type of stuff. So potentially 90% of it can still be done, but with enhanced surveying techniques, so you can actually understand that clash detection. So when you do go out, you only go out once, and that's
key.
A bit of a mantra.
So I did promise that we're going to abandon site and we're going to find our way to the fact that everything's been installed, and now you've been told that you have to run a bloody train back and forth under the wires for ages to be allowed to then energise, which, well, tell us a little bit about dynamic testing and explain. This is a good example of where all of us are told to challenge standards.
Yeah.
This is a bit of a case study in what that actually materially looks like.
Yeah, so as part of our SPL's contract, we have, and there's a legal requirement under the NTSNs, which is our new legal framework post-Brexit. So people might have heard of interoperability, or TSI. So the TSIs have now migrated into our NTSNs, and part of that, if you're deemed CSM significant, which a major electrification project is, then you've got to you fit under the legal framework of the NTSN, and it's quite clear that anything above 75 miles an hour, you've got to test the overhead line system. And there's 2 types of tests. There's force trace via pantograph, and arc testing, which is what we don't do. So what does that mean? It means once we finished our overhead line and physically complete the works, we've got to run a train, an instrumented train, at the appropriate line speed. So if it's 110 or 125 miles an hour, we've got to find a train that does those relative line speeds. We've got to find a pantograph, an interoperable pantograph, and then we've got to instrument it. So, and that's what I've been spending.
Very simple. All that's
really
very simple. Yeah, absolutely simple.
So the last 18 months I've been working on trying to produce this train. We've now got this train. It consists of 2 HST Class 43s, which is 2 power cars that I think were designed in the 80s. So they go 1, 2, 5. 4 Mark III carriages for enhancing brake force, and a Class 91, which is an electric vehicle. Now, for the Class 91, we've got to take the pantograph off that and put a new pantograph on it, and we've got to instrument it. and we got to do, I think, in excess of 30 test runs to make sure the consist works, everything speaks to one another, and then it's needed for compliance. So i.e. we put the pantograph up, it tells us lots of ones and twos, and we've got to write a report, and then that's the end part of authorization. So it's needed to support a technical file that allow passenger services to run a middle and main line. So it's absolutely needed.
And it's a ruddy great lump through your Gantt chart, right?
Yeah.
In the program, that is not a short and easy thing to achieve, is it?
No, it's not. No, generally speaking, you've got to wait for the system to be energized. We did plan to do it on earthed infrastructure, so it was complete, as in construction complete, but we actually undertook the works. We're going to plan to do the works, and that would have been a first of a kind, but our program has slipped, but energisation has stayed the same, so actually doing it post-energisation. Where Gareth was talking about is there's intent, particularly from the Department for Transport, to challenge the very framework that we work within, so the NTSNs, and ourselves, RIA, and the technical authority have all been asked to challenge the over-onerous requirements within the NTSNs, and whether or not there's unviable requirements in there, such as this. So of all the, I think, 200 single-track kilometres we tested on middle and main line, it didn't yield any form of meaningful output to go back and re-snag it or rework it. So what's the point?
Yeah.
So we're spending a lot of money on something that yields no meaningful output other than a legal clause. Now, the legal clause is clear, but we're doing a lot of work in the background now to actually evidence that we don't need to do something. So we're challenging the very sort of legal framework that we all work in now. And for the first time in my career, there's appetite from the DFT, from government, whoever the government may or may not be, but there's appetite to actually change how we go to work, and we're changing that. So it's really positive for everybody.
Yeah, it's a really good example of, so we constantly, so from my perspective as a design engineer and contractors, we're constantly being told, challenge the standards, and often it's like, well, actually what that materially means is the Secretary of State for Transport is allowing us to manage risk in a different way, and that actually ultimately requires the Secretary of State for Transport sign-off, which they will not give particularly willingly. So actually they don't want us to change the standards, they just want us to hunt around and waste some money. This is an example of a material thing, a material change, which absolutely to the DFT's credit, which is not a sentence I say very often, absolutely to the DFT's credit, they've empowered the industry to take this, particularly this thing, which is this complicated train that is quite complicated to corral. Actually, they're not 80s. The 43s are from the blinking late 60s.
Oh, there we are.
So they're, early 70s sort of train. So there's this train of bits and pieces, this wacky-looking train with the pantograph, which is a pantograph that takes a long time to procure because, the long lead time and all these things.
Yeah.
And instrumenting. Hugely complicated process.
Yep.
And a railway, by the way, we don't have much capacity on, so when are you getting that train onto the network anyway?
Yep.
All of that to achieve what you then, it's like, well, what's it achieving? Well, 200 single track kilometres and nothing, no value at all. So what do you still need to have some form of validation, so what's that looking like? So this is where we get to the technology piece and that thing, so, things that are coming out of
there's a short-term view and there's a medium and long-term view. So the short-term view is actually understanding how the installed contact wire behaves. So we install in a validated system, those in the room who know overhead line, UK Mass Series 125, which is a system designed at Network Rail Own. We install that, and that goes through Network Rail governance, so what we call a Form E, which is entry into service requirements, and that's just static geometry. You might see guys with height and stagger gauges taking heights and staggers. What we're actually doing now, we've actually trialled a piece of technology that can actually go out on the back of an RRV and actually take the contact wire profile and actually plot it longitudinally at 100 mil increments, so we can actually plot the contact wire curve and the catenary curve. We can then give that to give that to a specialist consultant, and they can actually start doing a form of simulation.
They essentially run a virtual train under it.
Yeah, and they put multiple pantographs through it. So they can actually look at the static geometry against the installed geometry, or design against installed, and actually say, well, there's some issues here. You've got a kink in the wire here. You've got a dropper that may have come off there. So we can actually predetermine or do preventative maintenance and actually think, well, that could affect the running of the train or the operation of the infrastructure, so we can pin those out. But we can actually push through virtual pantographs and actually do multiple train testing at 1, 2, 3 pads. Now, we did this on London to Corby. The technology's got a lot better, and we're going to do it again London to Wigston, which is the next stage. And it all helps to build up a portfolio of evidence of saying, actually, as an interim step, we can use alternative technology or an Article 13 or 14 or innovation to fundamentally not do train testing.
We're finding it's not about ignoring the risk. It's about finding a new way to manage that risk and validate the.
That's right. So it's not for me to or those with electrification experience say this is a waste of time. You need to evidence that path, and that's what we are doing. So we've got to always evidence about the row and back of the requirements, but that's what we're hoping to do.
Now, I'm conscious there's quite a lot of interest. We could keep going for another half hour more, but I wanted to open to the floor, actually. Simon, thanks so much. That's been really good. But I want to open to the floor for questions, actually. Any questions? Stumped silence. Oh, yeah, here we go. There we go. Yeah. A little delay. There's a microphone. Oh, there's a microphone on its way. Briefly. I know, they're getting so comfy because it's the last shift of the day.
I think this is on.
Kev, go for it. Yes.
My credentials are that I'm chair of a rail user group, and it's on a line that's got the potential for electrification. So that's why I'm here listening to this. But a couple of general questions, really. One is around lessons learned. You mentioned about you learned how not to do it with the Great Western electrification. I'm sure we're all aware that there's an awful lot of electrified railway across Europe. And I'm just wondering if you've gone out of your way to learn from them, maybe adopt some of their products, some of their installation equipment. That was my first question. And the second one was, has the design been future-proof for climate change in terms of wind speeds, ambient temperature range and stuff like that?
Right, okay. First question then.
Learning from Europe. Somewhere in it.
If you look at our equipment already, I'd say, and I'm part of a great group. We're part of SPL Austria and Germany, so we do a lot of electric. Yeah. So we're owned by a bigger group who owned by Equans, who are owned by Bouygues, who own Colas. So we're part of this huge conglomerate, right? So and it's interesting because I speak to my counterparts. Now, hard to believe, perhaps, but they actually look at us in admiration because we're a lot more. We innovate a lot more than they do. If you look at high-speed system SNCF in France, for example, very effective, but they've always stuck to what they've always done. So where we have innovated, nobody in Europe is applying this VCC stuff that we are. They don't necessarily the voltage clearance stuff. They're not necessarily as ambitious as we are to drive down those costs. Now speaking to the Germans, their intent, their corporation want to innovate because they've got the same issues as us. There's no money, but they need to decarbonise. But they need to do something different. But they've got a lot more red tape than we have. And Network Rail, over the last 5 years, 5 to 10 years, have been a lot more progressive in terms of how they deal with technology. So I think we've got the best of both worlds.
Two ways straight.
Yeah. I think we pick what we want, then we keep what we want.
Yeah.
And that's not post-Brexit. I think we've generally kept.
Yeah. And I suspect that I'll answer your climate change question by saying yes, it's all in the standards. We very much do. The only change has been that recently we had to change the extreme high temperature limit from 38 to 41 degrees. I was speaking to Noel about this. Thanks to climate change, meaning that we are going to see 40-degree days in the UK somewhat more frequently than we expected, having had one already a couple of years ago. Next question. Sorry, at the back. Yes.
I'm the pasture rep on the West Midlands Combined Authority, which is Mayor Dan Norris. We've started a study for Chippenham to Bristol, Temple Meads, and through to Patchway Parkway to try and fill the gap using the combined authority, working with Department and New Labour government. So I think I was involved in the DIAs for the Great Western Main Line. So, I mean, it was highly expensive, and we've still got the posts are in the ground, but no posts gone up, if you get my drift.
Yeah.
We put the foundations in all the way to Oxford as well. So what are the lessons learned for Louise Haig and the new government then to bring the cost of that project down so that we can complete Great Western's electrification? I mean, it's the Welsh Government's decision about Swansea, but it's devolved. But yes, certainly,
Yeah,
can we get costs down? Because that, and effectively also, we need to look at how we make the system fully accessible to cross and go through without adding cost of what is basically the Equalities Act 2010, and that's what we were doing. We made every station, platform lengthening, lifts, I was involved in fully accessible, but we still didn't do crossings and points, and that should not be the case in 2024 with the Labour government coming in.
So I'm going to answer both. So on accessibility, come back next year as well, because there'll be a panel session on accessibility and level boarding. So a very passionate subject of mine. In terms of the whole session, we've talked about bringing costs down, but in terms of the point to the new government, I think is something that's interesting and new for us to tackle, and I'll pick this one up, which is the work that Simon's been doing. The fact that the industry has put a huge amount of work into bringing those rates down, but also the need for there to be... we know what the end state of the railway needs to be, which is an electrified railway. A modern railway that is not electrified is incomplete. We know what that end state needs to be. So government need to commit to it at some point. So we just need to communicate to them that the longer they and ah and delay going, well, have you got that SDK rate down by the 0.1 that we want, percent that we want it, the longer they wait, the longer it's going to be until we fully electrify the network, and the likelihood of us hitting our net zero legal targets gets thinner and thinner. So, and not, by the way, from decarbonising railways, but by decarbonising transport by railways being better. So it's the data that we've got, it's the confidence we bring as an industry saying, no, okay, things have moved on since Great Western. Great Western was a big boom after a long bust. We've had another short bust again, but now things are ramping up. We're learning those lessons, and I think that's how we take that forwards. Is taking forward the data of the work that you've done, Simon.
I think the other question concerns my mayor, who's Labour, is also dealing with the air quality issues. We've got a fleet of extremely old, clapped out DMUs on First Great Western, which obviously needs a procurement programme to replace. Some 175s are coming over. But again, electrification is part of
It's that big. It's the whole picture, isn't it? And it's kind of come up again and again in the previous sessions we've had here today and yesterday, that big picture, by the time we're collecting, this is kind of quite a neat way that I think I'll wrap up today, that big picture has to be seen. We have to move into a space where the whole industry is being seen as a single industry collectively, no matter what the structure ends up being. And I think for me, that's the key thing. And as I say, Simon, the work you've been putting in helping build that picture from an electrification perspective is really, really important. Everyone, I'm conscious of time and that everyone needs to escape desperately to watch some football. I will say thank you for the last time in the last 2 days to Pandrel. Pandrel, thank you so much for supporting this, the Engineering Theatre. Thanks everyone, all of you, for attending this last session. Lastly, Simon, thank you so much for that. That's been absolutely brilliant. Everyone, thank you, Simon, terrific.